When we talk about measuring an AI's intelligence, especially its ability to predict the future, what's the first thing that comes to mind? For most, it's accuracy. But what if I told you that the most statistically accurate AI is often not the most profitable one? In this explainer, we're going to dive into this fascinating paradox and explore two very different ways of defining AI intelligence. This single sentence is really the heart of the matter. It's the most critical and frankly counterintuitive finding from a project called Prophet Arena. This statement forces us to question how we even define and measure AI intelligence, and it sets up the central puzzle we'll be exploring. You see, this paradox reveals two competing models of intelligence. On one hand, you have the scientist. This model's goal is pure statistical accuracy. It wants its predictions to match reality as perfectly as possible over the long run. But on the other hand, you have the value investor. This model's goal is completely different. It's all about finding value in making profitable decisions, even if that means not being perfectly precise all the time. So where did this discovery come from? It came from a unique platform called Prophet Arena. It was specifically designed to be a rigorous, uncheatable testing ground for an AI's ability to see into the future. Now, why is a platform like this so necessary? Well, it's to solve a huge problem in the AI world known as benchmark contamination. You see, many AI tests are flawed because the models have already seen the test questions or something very similar in their training data. So when they get a high score, are they actually reasoning or are they just remembering? Prophet Arena gets around this by using future real-world events that haven't happened yet as its test questions. The process itself is very methodical. First, it finds real-world events that haven't been resolved yet, pulling them from prediction markets. Second, it gives every single model the exact same standardized briefing. This ensures a level playing field. Third, the models submit their forecast, their probability, along with a written explanation of why they think that. And finally, once the event actually happens in the real world, the models are scored on their performance. It's this four-step process that gives us such robust data. And that brings us to the scoring. This is where things get really interesting. You see, Prophet Arena doesn't just have one leaderboard. It has two, and each one measures a completely different kind of intelligence. This dual metric system is the source of our paradox. The first metric is the Breyer score. You can think of this as the scientist's metric. It's all about pure statistical accuracy and calibration. To get a good Breyer score, your predictions need to match real-world outcomes over time. So if you say something has a 70% chance of happening, it should happen about 7 out of 10 times. It penalizes you for being overconfident and for being underconfident.
The second metric is average return, and this, of course, is the investor's metric. This score simulates a betting strategy. It takes the AI's prediction and pits it against the market's odds. And here's the key. It doesn't just reward being right. It rewards being more right than the market consensus. It's all about finding where the collective wisdom has gotten the price wrong.
And when you compare these two paths, you see how different they are. For the Breyer score, the scientist path, consistency and perfect calibration are everything. And here, the big, well-trained models like GPT-5 tend to excel. But for average return, the investor's path, the winning strategy is totally different. It's about finding those high-value, often contrarian bets. And in that arena, a smaller, more specialized model called O3 Mini was the undisputed champion. Okay, let's look at some real examples to make this concrete. Because what we find is that different AIs start to develop their own unique strategies. You could almost call them personalities. Our first case study features our top-performing investor model, O3 Mini. The event in question was a Major League Soccer match, and in this match, the team Toronto FC was seen by just about everyone as the clear underdog. In this one single event, O3 Mini's contrarian strategy produced a simulated return of 9 times the initial investment, a 9x return. So how did it do that? It wasn't magic. It was about spotting mispricing. The market had priced Toronto's chance of winning at just 11%. But O3 Mini, after analyzing the exact same data as everyone else, calculated their chances at 30%. That massive gap between its own assessment and the market's signaled a huge opportunity, and when the underdog team actually won, that bet paid off big time. These models also show very different tolerances for risk. For instance, when asked to predict the fate of an AI regulation bill, one model, QN3, was very aggressive. It predicted a 75% chance of the bill passing. But another model, Llama 4, Maverick, was much more conservative, giving it only a 35% chance. Now, this is a crucial point. These distinct strategic personalities, the aggressive one, the conservative one, the contrarian, they aren't programmed in by developers. They are emergent properties. They arise naturally from a model's underlying architecture and its training as it wrestles with these complex, real-world problems. All of these findings really point toward a new paradigm in how we think about AI development. We're seeing a shift away from systems that rely on static knowledge towards systems that are capable of dynamic, real-time reasoning. The data from Prophet Arena shows a very clear hierarchy. The models that consistently perform the best are not your standard large language models, which are trained on a fixed data set. Instead, the top performers are a different class of system we call think and search agents. These agents can actively go out, search for new information in real time, and then reason through it in multiple steps.
So why do these agents consistently outperform human markets? Well, it comes down to a few key advantages. They can systematically process massive amounts of information without getting tired. They operate without the emotional biases or cognitive blind spots that we humans have. This allows them to find and exploit tiny but persistent market inefficiencies. And over time, those small advantages compound into a significant edge.
All of this, of course, leads to the ultimate practical question. Can these models be deployed as fully autonomous investors in live, real money markets? The answer, at least for now, is no. There's still a significant gap between the simulation of the arena and the messy reality of the market. For one, in the real world, if you try to make a large trade, the price moves against you, and your edge can disappear. The arena also uses clear-cut events, not the fuzzy, complex problems of global markets. And it neutralizes the speed of information, which is a huge factor in real trading. So the primary conclusion here isn't that we've built some kind of push-button oracle that can print money. Instead, we should see these AIs as incredibly powerful analytical partners. And this really points to the path forward. The true value is in human-machine collaboration. It's about using these different AI personalities to help us identify opportunities we might have missed, to stress test our own logic, and to act as a guardrail against our own cognitive biases. The goal isn't to replace human insight, but to augment it. And that leaves us with a critical question. How do we design the collaborative systems that best leverage the unique strengths of both human intuition and machine reason?